Welcome. If you want a career in information technology, your very first adventure starts right now. Before you can jump into cool stuff like cybersecurity or the cloud, or even helping people with their computers, you have to learn the most important skill of all: networking. It's the language that all technology speaks.
Think about it. If you want a job protecting companies from hackers, you've got to know how they use the network to get in. If you want to work in cloud computing with giants like AWS or Azure, you have to understand how we connect to those massive data centers. And let's be honest, if you work at a help desk, the #1 problem you're going to solve is, why can't I connect to the internet? Networking is the rock-solid foundation for your entire IT career.
So, for our adventure today, we're going to use two different maps to guide us: the Cisco CCS Networking Certification and the Pearson IT Specialist Networking Certification. You can think of the Cisco path as learning the why, the big ideas behind how networks work, and the Pearson path is more about the how, the hands-on, practical skills you'll need for a job right away. By getting a feel for both, you'll be ready for pretty much anything.
Okay, so let's get into it. What is a network actually made of? What are the basic pieces you'll find everywhere, from your own house to a huge company? Let's break it down.
It's really that simple. A network is just a bunch of devices that are connected so they can work together. The second your phone connects to Wi-Fi to watch a video, boom, it's on a network. When you send a paper from your laptop to a printer without any wires, they're talking to each other on a network. It's all about connecting things and sharing information.
To make this all super easy to understand, I want you to remember one big idea, an analogy we'll keep coming back to. A network is just like a city's postal system. Your computer, your phone, the printer, those are all houses. The information you're sending, the data, that's the mail. And the network cables or the Wi-Fi signals, well, those are the roads that connect all the houses. If you can remember that, everything else we talk about today is going to make so much sense.
So, all the parts of a network can be put into 3 simple groups. First, you've got end devices. These are the things you actually use: your laptop, your phone, a game console. In our little story, these are the houses. Second, there are intermediary devices. These guys are the traffic directors, like mail sorters at the post office. They make sure the mail gets to the right house. And third, you have the network media. These are the actual roads themselves, the physical cables you can touch, or the invisible Wi-Fi signals that carry all the information.
All right, you're going to hear these two words, LAN and WAN, all the time in your IT career. A LAN, or local area network, is a network in just one place. Your Wi-Fi at home? That's a LAN. The network at school? Also a LAN. A WAN, or wide area network, is what connects a bunch of LANs together over a huge area. And the internet? Well, that's the biggest WAN in the entire world, connecting billions of LANs. Getting this difference down is super important for exams like CompTIA Network Plus, and for understanding how cloud stuff like AWS works.
So, if your computer is in one city and it needs to get information from a website in a whole other country, how does that even work? How does the data know exactly where to go? Well, it's not magic. It's a system with rules and addresses, just like our postal system.
Here's the secret. Every single device on a network, your phone, your laptop, a web server, needs its own unique address. We call this an IP address. Without it, information would never find its way to your computer. It's exactly like trying to send a letter with no street address on it. It would just get lost. The IP address makes sure your data gets delivered to the right digital doorstep.
Seriously, this is the most important analogy to lock into your brain. Just like your house has a specific street address that nobody else on your street has, your computer has a unique IP address on the network. When you go to a website, your computer sends a request to that website's IP address. Then, the website sends the information right back to your IP address. Simple, right? Okay, let's talk about the two most important traffic directors, a switch and a router. A switch helps devices on the same local network, the same LAN, talk to each other. It's like the local mail carrier for just one neighborhood, delivering letters between houses on the same few streets. A router has a totally different job. It connects different networks together. It's like the main post office that sends mail from your city to a completely different city. The router in your house is what connects your home LAN to the giant internet WAN. I can almost promise you will see a question about this on the CompTIA A+ and Network Plus exams.
So where does all this information on the internet actually live? It lives on computers called servers. A server is just a really powerful computer that's always on, always ready to serve up information. When you watch a YouTube video, you're getting it from a video server. When you check your email, you're connecting to an email server. In our postal system analogy, servers are the destinations,
the businesses, the libraries, the stores you're sending your mail to. Now, can you imagine having to memorize the IP address for every website you visit? That would be impossible. Thankfully, we have a helper called DNS, the Domain Name System. Just think of DNS as the Internet's phone book. You type in an easy name like google.com, and DNS automatically looks up the correct IP address number for the computer. We also have another helper called DHCP. When you connect your phone to a new Wi-Fi network, DHCP is like a friendly receptionist that automatically gives your device a temporary IP address so it can get on the network. These two helpers work in the background to make the internet easy for all of us.
Let's be real for a second. Networks break. The Wi-Fi goes down, a website won't load. It happens. And when it does, people need a hero. With the skills you're learning, that hero can be you. Learning how to figure out what's wrong and how to fix it is called troubleshooting. And believe me, it is the most valuable superpower you can have in IT. This four-step process is your secret formula for success. It works for pretty much any problem in IT. 1. Figure out what the real problem is by asking good questions. 2. Check the simple stuff first. Is the cable plugged in all the way? Is the power on? You'd be shocked how often that's the fix. 3. Test one solution at a time. If you change 5 things at once, you'll never know what actually worked. And 4, write down what fixed it. This helps you fix it faster next time and helps your teammates too. This logical method is a huge part of what the CCST and IT Specialist exams will test you on.
Every hero needs a toolkit, and these 3 commands are your first and most powerful tools. First up is ping. It's the simplest test there is. It's like shouting to another computer across the internet, "Hey, are you there?" and waiting to hear if it shouts back, "Yep, I'm here." It's the fastest way to check if you can reach something. Next is ipconfig. This command shows you your own computer's IP address and network details. It's like looking at the return address on your own envelope. And finally, there's tracered. This tool is amazing. It shows you the entire road trip your data takes to get to its destination, every single router it stops at along the way. It's like a GPS map for your data packets.
Okay, so we've learned the basic language of networks, and we've looked at our first few tools. Now let's see how this knowledge actually shows up on the certification exams. We're going to look at a couple of sample questions so you can see what to expect. All right, here's a typical question. Take a second and think about it. A user needs to connect their home office network to the internet. Which device is required to perform this function? Now remember, what are we doing here? We're connecting two different networks, the small home network, a LAN, and the giant internet, a WAN. So which device has the job of connecting different networks?
The answer is C, a router. And why is that? Let's go back to our analogy. A router is like the main post office that connects your city to other cities. It connects your local network to the internet. A switch only works inside one network, like the local mail carrier. A hub is just an old, dumb version of a switch you'll barely ever see, and an access point just creates the Wi-Fi signal. It doesn't connect you to the outside world on its own. See, if you get the main ideas down, you can figure out the answers.
Okay, here's another one, but this one is focused on troubleshooting. A technician is troubleshooting a computer that cannot access any websites. What is the first command they should use to test basic network connectivity? Think back to our hero's toolkit. What was that simple command that just asks, "Are you there?" The correct answer here is D, ping. When you're troubleshooting, you always start with the simplest test possible. Ping gives you a fast yes or no answer. Can I even reach the other computer? ipconfig just tells you about your own computer settings. And tracert is what you would use after a ping fails to find out where the connection is breaking down. This focus on the correct order of operations is exactly what you do in a real IT job. And just like that, you've learned the core concepts of networking. You know what a network is, how devices use addresses to talk to each other, and the first steps to take when things go wrong. You are absolutely ready to begin your certification adventure.
As you keep studying, please keep these key ideas in your mind. First, really use those analogies. The postal system, the house address, they make tough ideas easy to remember. Second, practice with the tools. Open up a command window on your own computer and try typing ping google.com and then ipconfig. See what happens. Third, you have to master the difference between a switch and a router. It's the most important device concept. And finally, remember that everything you're learning here is a foundation. It's like building the first floor of a house. You'll build right on top of these same ideas when you study for Security Plus, for AWS, and for everything else in your IT career.
Always remember, every expert was once a beginner. Every single person working in a high-tech job started exactly where you are right now, learning these basics. So stay curious, Keep practicing and never be afraid to ask questions. Your adventure is just getting started. So, what will you learn next?